Good afternoon. We are live from my office here at the Air and Space Museum. I'm Emily Martin. I am a postdoctoral fellow here in the Center for Earth and Planetary Studies, which is on the third floor of the Air and Space Museum. I want to talk to you all today about the Cassini mission and its grand finale. The Cassini mission has been orbiting Saturn and Saturn's moons since about 2004 when it arrived. But before the Cassini mission, we actually had flown a few spacecraft by Saturn and the Saturn system, starting with Pioneer in 1979, and it glimpsed Saturn and its rings and its largest moon, Titan, shrouded in a very large, thick atmosphere. And the Voyager spacecraft actually in 1980 and 1981, Voyager 1 and 2 flew through the Saturn system and revealed a really diverse range of strange, beautiful worlds that were really, really intriguing. And they were so intriguing that in by 1982, scientists were actually already talking about how to go back to Saturn and explore the system, specifically the rings, Saturn's moon Titan, which was really intriguing because it's such a large world and the atmosphere was so thick that the cameras on Voyager weren't actually able to penetrate that atmosphere and see what the surface looked like, which made it even more mysterious and more exciting and so interesting that by 1983 they were talking about how they could go back to the Saturn system and maybe even land something on the surface of Titan and really start to explore it. So by the mid-90s, Cassini's in full swing, getting ready to launch October 15th, 1997 from Cape Canaveral. And it's actually a rather large spacecraft. I'm going to show you a model that I have here that was actually printed for us by the exhibits department here in the museum. And it's not totally complete. It's missing a few really tiny things that couldn't quite be printed by a 3D printer. And you can see this large magnetometer boom. The spacecraft itself, this distance here is about the size of a small yellow school bus. This here is actually the Huygens Probe. So this was actually, Cassini was actually the Cassini-Huygens mission. It was a joint mission between NASA and the European Space Agency. And this is the Huygens Probe. I'm going to turn it here a little bit so you can see it from another angle. The whole probe is inside this heat shield. And this whole thing is taller than an average size adult. I didn't have another way of showing you how big this was. But it's a rather large spacecraft. And so it was part of what's called the flagship class of spacecraft, which are the largest spacecraft that NASA produces. And it was sent 2.2 billion miles to the Saturn system. So like I said, it launched in 1997, and it arrived in 2004. Now, I actually didn't know an awful lot about this Cassini spacecraft when they were getting ready to put this mission together and start the planning phases. But I have this very distinct memory of Cassini arriving to the Saturn system in the summer of 2004. Now, I was an intern at what is now called the McAuliffe Shepard Discovery Center in Concord, New Hampshire. And they had a TV in the corner kind of by the entrance to the planetarium. And it streamed NASA TV. And I remember standing there and watching these images come in from the Cassini spacecraft of Saturn's rings really up close. Now at that point I had seen Saturn in sort of small telescopes doing some backyard astronomy, but I'd never seen them up close. Frankly, nobody had. And one of the things that Cassini had planned to do was really study the ring system in great detail. And so a lot of these early images in the early mid-2004 when the spacecraft first arrived to the system were really detailed images of these rings, and they were really, really captivating to the point where I didn't get an awful lot done that day at the planetarium. But being in college, I kind of forgot about the mission a little bit. Most of you will be surprised to know that I hadn't set my sights on being a planetary scientist early on as a child, so I was still getting interested in studying space as a career. So it wasn't until 2006, so almost 2 years later, that I was sitting in class and my professor walked in. If you were interested, it was a geodynamics class. Not important part of the story, but my professor walks into this classroom. There was probably 6 or 7 of us, and he brings in a scientific journal. Many of you may have heard of it. It's called Science. Looks like this. So this is the copy of the magazine that my professor brought in. And as you can see on the front, there is this, what looks like a planet to most people. I would probably call this a planet, although it's not actually a planet. This is Saturn's moon, Enceladus. It's quite small, actually, so it's about 500 kilometers in diameter. Think of the size of Washington State or Great Britain. It's actually relatively small when you talk about the sizes of moons. So he brings in and he shows us this, and he goes, these are some of the first results from the Cassini mission. And I was like, well, what the heck is that thing? It's very bright. Enceladus has one of the highest albedos, or the amount of sunlight that's reflected off of its surface. So it's as bright as freshly fallen snow. If you can envision going out on a winter day and on a really sunny day after the snow is freshly fallen, your eyes actually get kind of, it's very uncomfortable to look at the snow sometimes. That's how bright Enceladus's surface is. And then if you look down at the bottom, and I don't know if you can see this, I'm going to come even closer to you guys, these blue streaks down at the South Pole, those are actually what they started calling tiger stripes. Now, this was pretty cool. I hadn't seen anything like this before. I had seen images of Jupiter's moons from the Galileo mission, which were really intriguing, but I had a very strong reaction to this picture, to the point where I actually had to dig this up for you guys so I could show it to you. What gets even better is my professor started flipping through this article, and then he shows us this. I'm going to try and bring it close so you see if you guys can see this. What you're seeing here are two different images of Enceladus. One's an image and one is an image using a different kind of camera that looks at different wavelengths of light. And I remember seeing this and saying, well, gosh, that looks like an awful lot like a plume of some kind of water or some kind of material coming out of the South Pole of this moon. And that's a very intriguing result that came from the Cassini mission, because if you think about it, Earth is geologically active, right? We have volcanoes, we have a lot of weather that's going on. How many other places in our solar system can you think of that are actively doing something right now, like right now, like spewing lava or running rivers and lakes and water? Not a lot of them, right? So the fact that Enceladus is so tiny and it's doing so many different dynamic things was very, very surprising to me. And as a college undergrad, I was shocked by this. And so this was a really foundational moment for me. And so that was, still pretty early on in Cassini's prime mission, which went until 2008. So Cassini was so successful, and it was so... it was bringing back so many cool results that it was actually selected for 2 extended missions. The first was called the, oh no, the word went right out of my head. There was 2 extended missions, but the second extended mission is the Solstice mission, and that's the mission that we're in right now. And they're getting ready to end it on Friday, which is why we wanted to do this and share this with you all today so you guys could get ready for the Cassini's finale. But a lot of people have asked, why would you end such a successful mission? You have this huge, beautiful, healthy spacecraft that's flying around Saturn. Why would you decide to plunge it into Saturn's atmosphere? And part of this actually has to do with how successful Cassini was. Cassini brought back so many great results. And the two, I don't want to say they were the 2 best results, but 2 of the most intriguing results to me were Enceladus's geologic activity. You've got this plume, mostly made out of water, coming out of the South Pole, which means somewhere on Enceladus you have enough heat to maintain liquid water. We also had Titan. Now, I said a while ago, Titan is Saturn's largest moon. It has this really thick atmosphere, and we weren't really certain until Cassini dropped the Huygens Probe through the atmosphere to land on Titan's surface. And the continued flybys of Titan by the Cassini mission showed us that Titan is an incredibly dynamic place with lakes filled with liquid, dunes in the equatorial regions, extensive river valley networks, and all of the flybys that Cassini has made of Titan has actually shown us that these lakes are susceptible to seasonal changes. We actually see changes in the lakes as time has progressed. So Enceladus and Titan in particular turn out to be incredibly important places when you start talking about where in our solar system we might be able to find other kinds of life. Life that originated at those places and wasn't coming from Earth. Now, as Cassini has aged, it's actually started running low on fuel that it uses to change its course around Saturn so that it can visit all of these other wonderful places. But that fuel is starting to run low, which means eventually we're going to run out of we're no longer going to have the ability to control Cassini. And Cassini wasn't designed to land on any of these surfaces. And we have to protect all of these planets from any kind of microbes that might still be left on that spacecraft that we didn't bake off before we sent it off into space. And we want to make sure that when and if we're able to go back to Enceladus and Titan and we start asking questions about habitability and even start thinking about whether or not we can run experiments to test for kinds of life that we might see there, we want to make sure that we're not actually running tests on things that we left there. So before we accidentally crash Cassini into Enceladus or Titan or one of the other moons that we may go back to, we want to take the opportunity to do a controlled dive of Cassini into Saturn, Saturn's atmosphere, and actually make measurements that we would never have been able to make otherwise. So around April, I believe it was April 22nd of this year, Cassini started its grand finale, where it started making these dives between Saturn and its rings. Now, hold on, I'll be right back. This is a celestial globe that we're going to pretend is Saturn. So pretend that this is Saturn and pretend that this little band is actually a huge ring system. So Cassini's diving through this really tiny gap right here between the planet and the rings. And it's doing 22 of these. And it started in April. And it's making these measurements that I don't think people really thought we would be able to do with Cassini. But because we know that we're going to end Cassini's mission by diving it into the atmosphere of Saturn, you can start to think of maybe some slightly riskier things that you would do with a spacecraft that you wouldn't do with a brand new spacecraft, right? A brand new spacecraft, you want to make sure you get your primary mission completed. But now that we're getting towards the end of the mission, we can do some riskier things with the spacecraft that we wouldn't have done otherwise. And so it was really exciting when it first made its first dive through the rings in April, because they didn't really know what was going to happen. They hoped that that would be a clear enough space without any debris that would risk the spacecraft, but they didn't really know. And so these dives have been incredibly successful, and when you're done here, I want you to take the opportunity to go look at images from these dives and look at some of the close-up stuff that they've seen from the rings. It's really, really spectacular. So the whole reason that they're ending this mission the way they're ending it is so that they have the ability to protect possibly habitated moons, moons that at least we want to go and look at their habitability. But it's also taking the advantage of making some really, really critical measurements that we would not be able to make otherwise. So it's kind of this silver lining. And if you were standing, now Saturn doesn't really have a surface, but if you imagine that it had a surface somewhere in there and you were standing there, as Cassini started going through Saturn's atmosphere, you would actually start to sort of see it burn up in the same way that a meteorite would burn up in Earth's atmosphere. Now, like I said, Saturn doesn't have a surface. But what's really great is Cassini's actually going to continue to send data back to Earth continually through its dive. Now, tomorrow, Cassini's going to take its last pictures. I know it's taking pictures of the place where it's going to plunge into the atmosphere. It's going to take pictures of part of the A-ring, and it's going to take a few other images and collect some additional data, and it's going to downlink that to Earth tomorrow, the 14th of September, around 5:45 Eastern Time. And then around 11 o'clock at night Eastern, you should be able to go online and actually see those images. But Cassini's going to continue downlinking data to Earth as it rounds Saturn and starts to plunge into its atmosphere. Now, there's no way of knowing when we're going to lose contact with the spacecraft, and when we lose contact with the spacecraft, that's when we know that that's the end of the mission. They're hoping that it's going to go to, I believe the latest estimate I've heard is 7:54 a.m. Eastern Time. So actually what you guys can all do is on Friday, if you wake up good and early, especially if you're on the West Coast, you can go to NASA's website, and I have a link, I don't know if you can see it, nasa.gov/live, and you can actually watch Mission Control during the last hour and a half or so of Cassini. This live stream will start at 7 a.m. Eastern. It'll go until 8:30. And then at 9:30 in the morning Eastern on the 15th, there will be a post-grand finale briefing that you can also watch from the same link. There's other links you can use. You can use Facebook, the NASA Facebook page or the JPL Facebook page to stream these also. But this link will get you to all of those different things that you can do. So I kind of want to end off with sort of a tribute to Cassini by telling you guys some of my favorite discoveries from Cassini. It's not necessarily the most important discoveries, but they're certainly my favorite. I've talked about some of them already. Enceladus's plume. You can tell I was really excited about that when that happened. And Titan's lakes. I thought Titan lakes were really, really incredible. And if you go online and you start Googling some of these images, you can actually see some of the time-lapse that they've done over the years that Cassini has been flying around Saturn and flying by its moons. And you can actually see changes in these lakes. You can actually see reflections off of these lakes. They're relatively shallow. I don't think I mentioned these lakes are not made out of water. They're made out of liquid methane and ethane sort of combination, which are hydrocarbons. And it's pretty cool because if you think about it, Earth is the only other place we know of where there is liquid on the surface, right? Titan's the only other place. Now, it's not water because water would freeze, but these more exotic compounds actually have sort of comprised this entire sort of hydrological system. Of course, it's not hydro, it's not water, but it's another kind of liquid. The dunes on Titan are really spectacular. All around the equatorial regions, specifically in regions called Xanadu, which I think is a really fun name. There's just these dunes everywhere. And we don't find dunes on a lot of other places because most of these dunes are created by the really dynamic atmosphere of Titan. I'm also really think that Iapetus's ridge is very cool. So Iapetus is a really pretty large moon of Saturn. It's pretty far away from Saturn also. And one side is completely black and one side's completely white. So it's like a black and white cookie. But then around the middle of it, so the black side, you have the white side, and then you have this ridge that goes around the middle of it that's sort of like an Easter egg, just stuck together. And so it's sort of this mountain range that goes right around the equator. And it's such a weird looking place with this big ridge around its equator that sort of looks like somebody duct taped it all together. Tethys is another moon of Saturn that a lot of people don't talk about. It's got a lot of craters and maybe not a lot of other activity that's been preserved on its surface. But some of the other cameras that aren't just visible cameras on the spacecraft have taken photos of Tethys, and they found these streaks that are sort of a reddish color that sort of go across the surface, and they're these kind of arcuate stripes of red. And they've looked at the images of the surface, and there's no geological structure or crater or ridge that is associated with these red lines. And so those continue to be a mystery, and I think those are pretty incredible. And then, of course, my personal favorite, I've done most of my work on Enceladus so far, and one of the questions people have is, Enceladus's south pole has this plume shooting water out into space. Fun fact, a lot of that material escapes Enceladus. It actually creates Saturn's E-ring, which is pretty great. Some of that material comes back to Enceladus eventually, but its north pole isn't doing an awful lot. And I don't know if we can turn and you guys can see this. This is an old picture of the north pole of Enceladus, and it's pretty low resolution, especially right in this region here, but you can see there's just an awful lot of craters. And there's some new images that have come out pretty recently that have shown that there's all these young cracks that are kind of coming through in and around this area. So while it's maybe it's not nearly as active as the South Pole, it's also probably not as dead as maybe we think it is. And that was definitely something that we haven't seen a lot of because those are relatively new images. So you can see that Cassini's, and that's just my favorite ones, right? I mean, there's so many other things that Cassini has done. But when Cassini makes its plunge on Friday, there's still some other things we can look forward to. One, we're going to still have all of this data archived from Cassini that we can continue to use, and we will continue to study. I know I'll continue to study it. But there's some other things that are going to go on in the outer solar system that you guys should look forward to. The first is the flyby of MU-69 by New Horizons. So if you don't remember, New Horizons flew by Pluto and returned some spectacular images. And that spacecraft, the New Horizons spacecraft, is continuing out into the Kuiper Belt, and it's going to fly by a Kuiper Belt object that they discovered called MU-69, which is going to give us additional imagery of a Kuiper Belt object, and the Kuiper Belt is just populated by thousands of these really interesting bodies that we actually don't know an awful lot about. So this is pretty fundamental, exciting science that's going to be done here, and that's going to happen January 1st of 2019, so that's not very far away. After that happens, you can look forward to the Europa Clipper mission. This is a mission that's going to return to one of Jupiter's moons, Europa. It was seen by Voyager. It was so cool that they sent the Galileo mission out to Jupiter to study its 4 largest moons, called the Jovian moons or the Galilean moons. And the Europa Clipper mission is going back to Europa specifically because we think Europa has a global liquid ocean underneath its icy shell. And when I say ice, I mean water ice. So think of it as like a giant ice cube, and you're floating around in space with icy shell and a liquid middle. And then it's got a rocky core in the center. And we think that there's a really good chance that Europa may actually be habitable and may even harbor some kind of microbial life. So the Europa Clipper mission is moving forward, full steam ahead actually, and so they're thinking about launching sometime in the early 2020s. With arrival to Europa in the mid-2020s to the late 2020s. Those dates aren't obviously set in stone yet, but that's something you can also look forward to. So I hope you all are enjoying Cassini. I hope you continue to enjoy Cassini. I encourage you to get online and actually just Google some of its images. I really love the NASA Photo Journal. That's a great way to go find images and press releases about some of these really cool things that Cassini has done over the length of its mission. And so if anybody out there has any questions, please go ahead and type those into the comment bar here, and I'd love to answer them.
Yeah, so we've got a couple of questions from David and Akshay around the fuel used for Cassini. Just what fuel was used and how do they maneuver the spacecraft?
So I don't know all of the details about how they maneuver the spacecraft, but I do know some of them. So actually Cassini has 2 power sources. They have fuel that they use to power thrusters that they can use to change the trajectory of the spacecraft, whether it's to slow it down and or speed it up, change its altitude. It also has these nuclear power sources at the bottom. We use these a lot. They're called RTGs. We use these a lot for outer solar system missions. These are on Voyager, these are on New Horizons, they're on Cassini, and they are very reliable, and we use them to power a lot of the instrumentation. So the fuel's just for course corrections, and then these RTGs provide power for all of the other instrumentation.
Claudine wants to know, how will NASA know Cassini's final dive is successful?
So it's already been, all of its other dives have been really, really successful. But its final dive, they're going to receive communication from the spacecraft as it enters its dive and as it goes into the atmosphere. It will be considered successful, I think, no matter what. But they'll know that the dive is done when they stop receiving communication from the spacecraft. So I guess success in this case is in the eye of the beholder in a way. I know that they really want to make measurements of its atmosphere and its atmospheric composition, and they'll get some of that right at the top. And I think they're very confident that they will actually receive communication from the spacecraft before it gets too deep. But I think it's going to be considered really successful if they make it to that 7:54 Eastern Standard Time in the morning. If they make it to that point, I think they're going to be really excited.
And last question, what advice would you give to people who are interested in kind of following a similar, career trajectory as you do?
Yeah, so if you remember I said earlier, I feel like I'm a little bit different in that I didn't have my sights set on becoming a planetary scientist when I was a kid. I thought space was pretty cool, but it never really extended beyond that. And it wasn't until I was in college, obviously I got pretty excited about Cassini when I was in college, but I was actually, at the time I was also working on a research project with one of my professors on one of Jupiter's moons, Ganymede, using data from a totally different spacecraft, the Galileo spacecraft. So my advice would be, read a lot, don't be afraid of math and science at any level, whether you're in middle school, elementary school, high school, college. Take as much math and science as you can take. My undergraduate degree is actually in physics. It's actually bachelor's of arts in physics. And that provided me a really great foundation. So ask a lot of questions, read a lot, and my motto is you don't get what you don't ask for. So ask your professors, be curious about things, and try and learn something about these spacecraft. You don't necessarily have to be involved in a mission that's ongoing today. I'm actually working on a project using Voyager data right now. And like I said, those Voyager flew by Saturn in the early 80s. So once that mission is over, it doesn't mean that data goes away, and it doesn't mean that data becomes irrelevant. So I would spend your time asking questions about these different places and talking about how you think certain things may have happened out there, and talk to professors about classes that you could take or projects you might be able to do with them, because a lot of this data is out there, it's available, it's free for you all to use also, and so it's there's a lot of opportunities out there to get yourself educated about these things.
Great. Thank you very much.
Thanks so much, guys. Bye.